There are three categories of work that we will focus on in this course. The first of those categories is called shaft work. Now, shaft work is any kind of work that involves a spinning shaft. So a turbine, a compressor, a fan, all of those are means by which a spinning shaft either adds energy to a fluid or takes energy out of that fluid. Flow work is defined as any work that involves mass movement across a boundary. So you can think of it as any time the actual motion of the fluid, that's the energy that it's getting. That's the flow work. One key note of this is that it's mass movement across a boundary. So by definition, a closed system says that no mass crosses the boundary. Therefore, you can never have flow work in a closed system. The third type of work is going to be moving boundary. So moving boundary, the most common type that you'll think of with this is going to be a piston. An example of this might be if your shocks on your mountain bike, expanding and compressing. A piston in an engine expanding and compressing. So you have that work of the expansion and compression, the change in that volume is the moving boundary work. There are other types of work such as spring, electrical, magnetic, but we're not really going to get into those in these courses. For this course, we're going to mainly focus on shaft, flow, and moving boundary. An example of a system in real life that uses multiple forms of or types of work is a turbocharger. So a turbocharger is a system in a car whereby you take the energy that's still around in the exhaust that comes out of the engine, and you use that energy to increase the flow of the air intake going into the engine. More oxygen gets you a better performing engine. So we take what's that leftover energy of all that that dirty exhaust coming out of the engine and try and put more use to it. So we can really analyze the turbocharger as two separate systems joined together by a shaft. So on the left we have the exhaust system. We have the exhaust incoming into this system, coming into these swirl vanes. It goes through the turbine and then exhausts out to the left. This exhaust system is connected by a shaft to the intake system. So the intake system, the air, the clean air, comes in from the side, hits that compressor, and shoots out of the intake out the top there. Now, if we look at these in energy standpoints, from the exhaust side, we have flow work coming into the system through all that energy of the exhaust. It hits the turbine blades and creates turbine shaft work going out of the system. Now, if we think back to when we talked about hip to win, the flow work is coming into the system. As you can see, in relation to the way how we drew the system, the arrow is pointing in. So hip to win, work in is negative. So the flow work should have a negative sign attached to it. Consequently, the turbo shaft work, the arrow is going out of the system. So in relation to the exhaust system, that shaft work is going out. Therefore, it should be positive. Now that turbine shaft work, that shaft from the turbine is then connected to the compressor. So in terms of the intake, the shaft work to the system is coming in. So now the work in is negative. So in regards to the intake system, that shaft work is now negative. You can see it goes through, it gives energy to the air, and then the air provides flow work coming out. So now we have positive flow work coming out of the intake side. So it all depends on how you draw your system. When we talk about hip to win, talking about sign convention, it depends. Heat in positive, work in negative, and then make sure you identify how you draw the system to know if it's coming into or out of your system.